Welcome, dear students. 2022 Unit-3 Mechanics, paper CC-10, semester 4, Mathematics Honors. Question paper 2022 Unit-3. Question 4a. Deduce the tangential and normal components of velocity and acceleration of a particle moving in a plane. Note that in this problem, no figure, no marks. So we must draw this figure. Let P be the position of a particle at any time t along a plane curve APQ given by the equation r vector equal to r vector function of s. S is the arc length of this arc AP, A being the fixed point on the curve. Let Q be the position of the particle at time t plus delta t such that arc PQ equal to delta S. Then PQ vector, this PQ vector equal to OQ vector minus OP vector. So this equal to delta R vector. So PQ vector equal to delta R vector. Now limit delta t tends to 0, delta R vector by delta t is equal to ddt of R vector is equal to velocity vector of the point P in the direction of the tangent, this tangent to the curve at P in the sense S increasing. So V vector equal to ddt of R vector and the modulus of V, magnitude of V equal to modulus of ddt of R vector. So V equal to limit delta t tends to 0, modulus of delta R vector by delta t, this equal to limit Q tends to P. So this point Q tends to P in the limiting sense, chord PQ by delta t. That is, limit Q tends to P, chord PQ by arc PQ into delta S by delta t. So limit delta t tends to 0, this delta S by delta t, because limit Q tends to P, chord PQ by arc PQ equal to 1. So this ddt of S. Hence V vector equal to ddt of R vector, this equal to ddt dds R vector into ddt of S. So ddt of S is V, and this so this equal to into t cap. This t cap is the unit vector along the tangent TP. Actually, this equal to t cap is the direction of V vector. So V vector by modulus of V, that is V vector ddt of R vector by this magnitude is V is the ds dt. So this ds dt. So actually dds of R vector. So dds of R vector equal to t cap. T cap is the unit vector along the tangent. The equation 1 shows that the tangential component of the velocity vector v at p equal to v, that is equal to ddt of s, and the normal component of v vector at p is 0 because this normal component is v vector into cos 90. This normal component is the 90 degree normal component pn along the pn with the tangent is 90 degree. So v vector into cos 90 equal to 0. So normal component of this velocity vector equal to 0. So actually v vector equal to this breaking along the tangent along the normal. So we get v t cap plus 0 into n cap, where n cap is the unit vector along the normal pn at p in the sense of phi increasing, where phi is the angle made by the tangent tp with the positive direction of the x-axis. So this is the phi angle, the positive direction of the x-axis, and this is the increasing direction of psi, increasing direction of psi. So increasing direction of psi is this direction. So pn is the positive direction here, n cap, direction of n cap. From the above figure, t cap equal to I cap cos psi plus j cap sin psi. Note that from this the point T cutting the tangent to the x-axis, and this is the I cap unit vector along x-axis, and j cap is the unit vector along y-axis, and t cap is the unit vector along the tangent and the direction TP, and this psi is angle this. So obviously, t cap equals to this the I cap cos psi plus G cap sin psi. And n cap, actually n cap is the in this direction, this mn, actually this is the mn, actually from this figure, this mn, this direction. So this angle is psi, so this angle is 90 minus psi. This angle is 90 minus psi. So this angle is 90 minus psi. So this angle is psi. So this direction, positive direction is I cap. So the negative direction is minus I cap. This direction is J cap. So n cap in this direction, normal direction, mn direction. So this equals to minus I cap into cos of 90 minus psi, that is sin psi, plus J cap cos psi. Differentiating 5, derivative of t cap, this equal to minus I cap sin psi, and derivative of cos psi is sin psi, plus j sin psi derivative is cos psi into this derivative of psi. Actually, this is the n cap from 6, so n cap derivative of psi. And derivative of n cap from 6 is equal to minus common I sin psi derivative is cos psi, and cos psi derivative sin psi into derivative of psi. Actually, this is the t cap, so minus t cap derivative of psi. Differentiating 1 with respect to t. Equation 1, this is the v vector equal to v into t cap, differentiating 1 with respect to t. So we'll get the acceleration vector f vector equal to derivative of v vector, that is derivative of v into t cap. So this equal to derivative of v into t cap plus v into derivative of t cap. This t is time, and this t cap is the unit vector along the tangent TP direction. So a vector equal to derivative of v into t cap plus v into derivative of psi into n cap by 7. This equation 7, derivative of t cap equal to n cap into derivative of psi. So from 7 we get this, and derivative of v t cap plus v into 1 by rho, is the rho is the radius of curvature of the curve at the point P. So actually this is equal to dd psi of s, and v is the derivative of s. So put these values 1 by rho into v into n cap. So f vector equal to derivative of v t cap plus v square by rho n cap. So the tangential component of the acceleration vector f is the ddt of v, that is equal to d2 dt square s or v dds of v, and the normal component is the v square by rho, is the v square by rho or v square dds of psi. Next question 4b. A particle describes a path with an acceleration mu y to the power minus 3, which is always parallel to the axis of y and directed towards the x-axis. If the particle is projected from a point A with coordinates 0, a with velocity root over mu by a parallel to x-axis, then show that the path described is a circle. This is the figure diagram. This is the x-axis, this is the origin O, the y-axis, this particle, this acceleration mu y to the power minus 3 always parallel to the x-axis of y and directed towards the x-axis. So this force F, actually this force F is the mu y to the power minus 3 always directed to the parallel to the y-axis and directed to the x-axis. So this direction. And if particle is projected from the point A, this point A, this parallel to the x-axis. So this initial velocity is v0, say at the time t equal to 0. Then particle is the path of this particle is this. At time t, this is the position of the particle at time tp. The equations of motions of the particle are this mx double dot. Actually, x double dot means d2x dt square equal to 0, and this at this point p. there is no force along the x-axis. So this is equal to 0 force, and this is the my double dot. Actually, this my double dot equal to m d2y dt square. This equals to parallel to the y-axis and towards the x-axis. So towards the x-axis, this means negative sign here. M into mu by y cube. Here is the mu is a positive constant, and m is the mass of the particle P. So this negative sign here, because this force is towards the origin. So this is the force negative here. Only the force parallel to the y-axis here. Integrating 1, we get x dot, that is dx dt, equal to constant c, integrating constant. And initially, at that time t equal to 0, this x dot equal to root mu by a. Actually, x dot means the velocity v0. Given that this the velocity root mu by a parallel to the x-axis. So x dot equal to this. So obviously, c equal to this. Hence, from x dot equal to c, so x dot equal to root mu by a. Multiplying 2 by multiplying 2 by twice y dot, that is 2 derivative of y, and we get this 2y dot y double dot equal to minus mu by y cube 2y dot, this 2y dot derivative of y dot minus 2 mu 1 by y cube derivative of y, and this y dot dy dot uh, as it cancel ddt from both sides, so this minus mu by y cube and dy. Integrating, we get y dot square by 2 equal to minus mu by minus 2y square plus c1 by 2 for adjusting the constants 2. So c1 by 2 is the integrating constant, and this initially when y equal to a, y dot equal to 0. Initially when y equal to a, and this coordinate, this x equal to 0, y equal to a, so y equal to ja, and this y dot equal to 0, because this velocity, initial velocity, is parallel to the x-axis. Particle projected from this point, velocity parallel to the x-axis only. So there is no component along the y-axis. So this y dot equal to 0 here, and this from this y dot equal to 0 put here, and this y equal to a. So c1 equal to minus mu by a square, and putting this value of c1, this y dot square equal to this, and so y dot equal to minus root over of a square minus y square whole divided by ay. Here negative sign is taken because this y decreases with time t increases, since the acceleration always directed towards the x-axis. So so this accelerated towards the x-axis. So y dot is negative here. Y decreases with time t. And from 3 and 4, this equation 3, this x dot and y dot from 4, and divide 3 and 4, and divide 3 by 4, and this y dot by x dot. So we get cancel a not equal to 0, mu not equal to 0. So dy dx, actually dy dt by dx dt, so dy dx equal to this, and separating variables, this integrating, we get this c2 is the constant of integration, and put a square minus y square equal to z square. So we get this initially when x equal to 0, y equal to a. This is the point coordinates with 0a. So c2 equal to 0, hence we get x square plus y square equal to a square, which represents a circle with center at origin and radius a. Hence the required path is a circle is given by 5. Next question, question 4c. An engine is pulling a train and works at a constant rate doing h units of work per second if m be the mass of the whole train and r be the resistance supposed constant, so that the time required in generating a velocity v from rest is this seconds. Here the pulling force, this is the train with engine, this mass is capital N, and this velocity capital V, and this is the uh, engine pulling force is this P in this direction, and this the R is the corresponding resistance force, the opposite to the velocity direction. So pulling force is P units, and the works concentrated being 8 units of work per second, and capital V with the velocity of the train at time t. Then H equal to P into V. putting force into this velocity is equal to uh, work. This H is the uh, work, doing work per second, unit per work second. So this P equal to pulling force equal to H by V. Let constant force of resistance R units. The equation of motion of the train is this acceleration m into ddt of V is P minus R. This is the in this direction positive direction P, and so this is the negative direction, so P minus R. So we put all these values, and after simplification we get this. If the train starts from rest and attains the velocity v at time capital T, so integrating this 0 to capital T dt, integration 0 to capital V at time capital T, velocity attains this capital V. So integrating limits is this 0 to V, this small v, velocity at time any time T. So after simplification we get this, and integrating we get this result, limit 0 to V, and putting this we get this result, this prove this result. Next question, question 4D. A particle is projected from the lowest point with velocity u and moves along the inside arc of a smooth vertical circle, so that if u square greater than equal to 5 ga, then the particle reaches the highest point and makes a complete revolution of the circle. And this is the figure. So no figure, no marks. Must draw this figure. Let a particle of mass m be projected from O, the lowest point of the smooth particle circle of radius A, and the center is C. Figure is self-describing, and this is the tangential velocity V, the normal reaction, this R along PC, and this the particle downwards, the weight of the particle, this, and this angle is psi with the positive direction x-axis, and this tangent and TP in the anticlockwise sense. And so this is the mg sine phi sine psi, and this direction is the mg cos psi. So equation motions of the particle p at any time t is equal to mv ds of v is the acceleration equals to minus mg sine psi. Actually, this is the minus mg sine psi because this direction towards O, towards the x-axis. So this is the minus negative sign. And mv square by rho, normal component. Actually, here rho is the radius of curvature. Here for this circle, radius of curvature is A radius. This is equal to R, and this direction is the increasing direction of psi. So in this direction, PC direction is the positive direction, and this direction is negative direction. So R is in positive direction, increasing direction of psi. So R minus this direction mg cos psi is negative direction, so minus mg cos psi. Now sin psi equal to dds of y, and psi is the angle is this, and S is the arc OP. This the O is the fixed point, this OP. And from 1 we get v dv equal to g in dy minus d dy, because sin psi equal to dy ds. So we get this. Integrating we get v square by 2 minus gy plus c is constant of integration. At O, initially v equal to u, y equal to 0. At this point O, y coordinate 0, 0, so y equal to 0, and this initial velocity, this u, so v equal to u, and so from this c equal to u square by 2, and putting the value of c u square by 2, after simplification we get v square equal to u square minus twice gy, and this equal to this y equal to on, this y equal to on, actually this on distance equal to oc minus cn, oc minus cn. Actually oc is the radius a, and cn is the a cos psi, a cos psi. This is the this angle is psi, so obviously this angle is psi, and this radius is a, so obviously cn is the A cos psi. And from 2, R is the mv square by A plus mg cos psi. So R equal to this, putting the value of V square here from 3, and after simplification we get R equal to m by A bracket u square minus twice Ga plus 3Ga cos psi, equation 4. For a complete revolution around the circle, V and R must be positive everywhere. Now when psi increases, cos psi decreases, this from 0 to pi by 2 angle. So cos psi is this. So cos psi is decreasing function from this 0 to pi by 2. From 3 and 4, both V and R decrease with psi increases. The highest point A, psi equal to pi. At the highest point A, this is the highest point A. This angle is psi. So when psi equal to pi, so this point A, we get this point A, highest point A. So psi equal to pi from this, put V square equal to this when psi equal to pi. So cos pi equal to minus 1. So this 2 and 4 u square minus 4 Ga. And from the equation 4, when cos psi equal to pi, psi equal to pi, so equal to minus 1. So this minus 2Ga minus 3Ga, actually minus 5Ga. So n square by A at this point A, highest point this. And these are the least values of V and R respectively. Hence, if U square is greater than 5Ga, both V and R remain positive, and the particle will make a complete revolution along the circle if U square greater than 5Ga. And if U square equal to 5Ga, from 6, this reaction is 0 at the highest point, but the velocity is equal to root over this u square is equal to 5Ga, so 5Ga minus 4G equal to Ga, so V is root Ga in the magnitude. And this positive velocity, hence the particle will continue to move along the circle and moves completely around it. Thank you for watching this video, and the PDF of the solution I have given in the description box. Thank you.